Let's consider briefly the things that would tell us whether or not we have had a chemical reaction when we mix our chemicals. So, if we saw a temperature change when we mixed our two reactants, that would tell us we had a chemical reaction. If we had a color change, that might tell us we have a chemical reaction. If bubbles formed, if we, for example, throw magnesium into hydrochloric acid, the magnesium is a silvery metal, the hydrochloric acid is a colorless liquid. When we put them together, we see bubbles forming and we see the magnesium dissolving. So these two things are happening, and that would clearly tell us that we are forming something that wasn't there before, and something that we did have, we no longer have. Definitely a chemical reaction taking place there then. Let's consider combustion while we're here. Combustion can either be complete combustion or incomplete. If we had complete combustion, we would need plenty of oxygen and we would get carbon dioxide. So, if, for example, we were to burn methane, which is a gas, with oxygen, then we would get carbon dioxide and water. If there's plenty of oxygen, there's really nothing else that we can do there because this is likely to be hot, and so we would get a gas or water vapor. So we have carbon, we have hydrogen, we have oxygen, and we are going to have a chemical reaction which is going to leave us with carbon, hydrogen and oxygen in different forms. That's pretty much all you could expect to see. So balancing this, we have carbon, one of each, 4 hydrogens. Well, we probably wanted 2 there then, wouldn't we? To have our 4 hydrogen taken account of, and our 2 oxygens then are taken account by that. So there we have a balanced equation. So what about incomplete combustion then? Well, here we don't have enough oxygen, and so we will produce carbon monoxide rather than carbon dioxide, and also maybe we produce some carbon soot. Now you might say, okay, so why are we so worried about these things? Well, the reason that we are so concerned about these things is our incomplete combustion leads us to producing carbon monoxide, which is poisonous. The problem with carbon monoxide is that it combines with the hemoglobin in your blood, which is what carries oxygen around your body, and it stays there. The oxygen, when it combines with the hemoglobin takes it in the blood to the cells and it leaves the hemoglobin. Carbon monoxide doesn't, it stays attached. And so you become progressively less able to take in oxygen when you breathe. And so it kills you. So slowly, but it does. So carbon monoxide is poisonous and dangerous as a consequence. Soot, well, soot causes global dimming, and also breathing it in causes respiratory problems. So it's important that when we are burning for heat, for fuel, that we get complete combustion. Otherwise we end up with carbon monoxide, which is toxic, and soot, which causes global and personal issues.